Good morning, everybody. Today we're going to take a quick look at section 10.2 from our books due to the cold and everything else. So let's get started. First of all, previously in chapter 9, we looked at hydrocarbons. Today we're looking at hydrocarbon derivatives. That means these compounds do not just have a C and an H, but they have things like oxygen, nitrogen, or even halogens attached to them. Right? Today we're going to be taking a look at the alkali halides, which means that they are the ones that have a halogen attached. We symbolize that with an X. The R, where you see that where it says RX, that R there is simply just talking about some sort of hydrocarbon chain. So anytime you see an R with this, it's just talking about a hydrocarbon chain. Okay, so hydrocarbons are typically got HC and H, but most commonly an O and N or a halogen atom will be attached to it to be a hydrocarbon derivative. Okay, and that is if it's a derivative. And typically, other than the hydrocarbon, this little feature with the oxygen, nitrogen, or halogen is known as the functional group, and it gives the unique properties of that particular compound. So alkali halides contain at least one halogen atom. We're talking fluorine, chlorine, bromine, iodine. We're not talking about astenine in this case. Astenine is a metalloid, not a nonmetal, and I've never really seen it come up, so I'm kind of assuming that it is simply not needed. They are synthetic compounds, meaning that they don't appear in nature. They are things that we have manufactured. Things like chlorofluorocarbons that you may have heard of are alkali halides, right? Chlorofluoro means it has a chlorine and a fluorine attached to a hydrocarbon chain. So, first of all, there's a long chain must be attached to halogen atoms, otherwise you can't have it. Now, the nomenclature is that the same as hydrocarbons, but the branch with the halogen is an O, not an il. So fluoro, chloro, bromo, iodo. Okay, and we just name it as a branch. In these cases, again, because each halogen only has one bonding electron, it's not going to have multiple halogens in a row, so it's just each one of those will be a branch onto its own. So for example, this one, we've got you see that there are two bromines and a chlorine attached to this hydrocarbon chain. Hydrocarbon chain is 6 carbons long, and so we would call that hexane. And we number the branches so that we wind up with the lowest number. So we get 2,4 dibromo 3-chlorohexane, right? Because we're numbering from this side. 1, 2, 3, 4, 5, 6. And so you see carbons 2 and 4, and carbon 3. And we're going with the alphabetical arrangement with that. So B comes before C, which comes before F, which comes before I. Taking a look at this arrangement, this is 1,4-dibromo-2-chlorocyclohexane. The big difference is that it's now in a circle, and so we can start numbering anywhere, but numbering from the bottom and going counterclockwise is going to generate the smallest numbers. Any other way will get you higher total numbers than 1, 2, and 4. Again, 2 bromines, 1 chlorine, but it's a cyclohexane. So, organic halides are hydrocarbon derivatives. They're functional groups named fluoro, chloro, bromo, and iodo. They're named as branches in front of the parent chains. They form compounds containing across a double or triple bond as well. We're substituting with the addition. We're substituting hydrogen across a single bond. So let's take a look at this one. 5 carbons across. On carbon 3 we've got the I, so this is 3-iodo pentane. Taking a look at this one, you've got 1, 2, 3, 4, 2 fluorines on carbons 2, 3, difluorobutane. Sometimes you'll see these things just placed right into rather than chain with the condensed molecular. And so we've got 1, 2, 3, 4, 5, 6, 7 carbons. On carbons 2 and 3 we've got the chlorine, so it's 2, 3 dichloroheptane. Here we've got the fluorine attached to the end branch, and so you do have 1 fluorobutane. And even with the straight chain, unlike hydrocarbons, you can wind up with a functional group on carbon number 1 because it is unique. This one here, you've got, again, 5 carbon chain on carbons 2, 3. We've got the chlorine, but we've got this double bond here on carbon 2. And if we numbered it this way, and so which takes priority? Well, the double bond takes priority. And so we'll call this 3,4-dichloro. Pent 2E. 1, 2, 3, 4, 5, 6, 7. On carbon 3 we've got the iodine, 3-iodo, 4, 5, 6, 7, heptane. And with this one, we've got a chlorine branch and we've got a methyl branch on a chain with 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons, numbering from this side to get the smaller numbers. You've got 5 chloro, 3 methyl nonane. Okay, I do hope that helps with the halogens. If you do have any questions, please let me know.